We're now going to spend the next 2 days of videos really digging deep into what it looks like to do these trig identity problems. So if you don't remember any identities, you have to go back to day one, study your notes, look at the video again, see where they come from so they can end up going in your brain. But remember, in order to be good at trig identities, you have to do two primary things. You have to know your identities like the back of your hand, and you have to be pretty good at algebra. So, some strategies that help a lot, changing everything into sine and cosine if you don't really know what to do. And then there are a lot of algebra things like getting a common denominator, getting complex fractions that are common, and then canceling things off, multiplying by a conjugate, factoring. Those are all things that we do. And so let's take a look at problem one. Let's start with the left-hand side. There are some problems where we will start with the right-hand side, but I think on all problems today on this video, we start on the left-hand side. So what I'm going to do is, in this problem, I'm going to look at the left, and I'm going to change everything into sines and cosines. So tangent, I'm going to rewrite as sine over cosine. And then, now that I've changed everything into sines and cosines, I can realize that sine times sine is sine squared. My goal is to get it to look like secant. And secant is really cosine in the denominator. And I already have something that has a cosine in the denominator, but my other term doesn't have cosine in the denominator. So that kind of leads me to believe that I want to get a common denominator. So I have sine squared x over cosine x plus cosine squared x over cosine x. That's because I'm multiplying the top and bottom of the second term by cosine x. Now I have a common denominator, so I have sine squared plus cosine squared over cosine. And sine squared plus cosine squared is 1. And 1 over cosine is secant. And now I'm done. Problem 2. I will once again work with the left-hand side. When I look at the left-hand side, I have 1 over tangent. I can rewrite that as cotangent. And now I'm going to get everything in terms of sines and cosines. So the first two problems, I'm primarily just using the fact that if I know my reciprocal identities and what tangent are, then, or what tangent is, then that helps me out a lot. So I'm rewriting cotangent and tangent in terms of sines and cosines. And now, remember, the goal is to get it to look like this. So I need a common denominator. And luckily, the common denominator will end up being sine cosine. So I multiply the first term by cosine over cosine. And I multiply the second term by sine over sine in order to get my common denominator. So when I do that, I end up getting cosine squared. I almost wrote in the wrong color, and that would have been sad, plus sine squared. And I know that cosine squared plus sine squared is 1 because of the Pythagorean identities. And that exactly equals the right-hand side. So that's problem 2. Problem 3, I will once again work with the left-hand side. And my goal is to get it to look like sine cubed. Now, in this case, remember yesterday there was a problem where I wanted to factor out the sine squared, but it actually didn't help me. In this problem, the greatest common factor of sine squared, or sine, is very helpful. I factor out the sine, and now I see that I have 1 minus cosine. Well, what I can remember is that sine squared plus cosine squared equals 1 can be manipulated, and so I can subtract the cosine squared from both sides, and that equals sine squared. So I can replace 1 minus cosine squared with sine squared. So I have sine cubed, and that is exactly the right-hand side. Now would be a good time to probably stop and note that I always keep the variable every time I write a trig function, whether it's x or theta or whatever the variable is. I want to keep the variable. If I don't keep the variable, if I just write sin cos or whatever, that is not referring to an actual trig function because functions need variables on the inside of them. So if you do not write the variable, you're probably going to get docked in terms of points, and it's mathematically inaccurate, which is more of the reason why we would dock you in terms of points. Problem 4. I will once again work with the left-hand side. What I'm looking at here is I probably want to get a common denominator in order to add the fractions, because when I look at this, when I look at the right-hand side, there's only one term, so I'm going to have to get common denominators in order to do that. So I'm going to multiply the first term by 1 plus sine squared, or not sine squared, 1 plus sine x. And then I'm going to multiply the second term by 1 minus sine x in both the top and bottom. So then after I do that, I can combine the numerators. Oh, right after I ranted about writing the variable every time, I then proceeded to not write the variable the very next time I wrote something. That's what you get for being high and mighty, I guess, when you're doing stuff. So I'm going to get the common denominator. Now, I'm in the interest of simplifying this a little bit faster. 1 minus sine x times 1 plus sine x. I'm going to actually multiply that out, and I get 1 minus sine squared x when I distribute everything. Now, I'm also going to distribute the numerator. I get cosine x plus cosine x sine x. That's the first term. Minus cosine x plus cosine x sine x. And so I just distributed both of those. And one thing to keep in mind is when I have a minus sign here and I distribute the cosine and the sine, that would be minus a negative, which ends up being plus a positive. So now I have all of this. The denominator simplifies to cosine squared using the Pythagorean identity. The numerator has the cosine x's cancel, and then I end up with 2 cosine x sine x, because when 1 plus 1 equals 2. Now notice I have a cosine in both the numerator and denominator, so one of those cosines ends up canceling. So I end up with 2 sine x, and then now there's only 1 cosine x in the denominator, and sine over cosine is tangent. And that ends up equaling exactly what the right-hand side is. Number 5, I will once again work with the left-hand side. In this case, I'm once again going to get a common denominator, so I'm going to multiply the top and bottom of the leftmost term by cosine x. And then I will multiply the top and bottom of the rightmost term by 1 plus sine x. So I just basically got a common denominator for us. Now I have cosine squared x. I'm going to put all of this over cosine x times 1 plus sine x. And now I will distribute that right term. So I end up with 1 plus sine x plus sine x. That ends up being 2 sine x. And then sine times sine is sine squared. Okay, a couple more things that I have to manipulate. I'm allowed to use the commutative property of addition. So if I have cosine squared plus sine squared, that's actually just 1. So I'm going to rewrite that as 1 plus 1 plus 2 sine x all over cosine x times 1 plus sine x. 1 plus 1 is 2, so I have 2 plus 2 sine x over cosine x times 1 plus sine x. And now I'm getting pretty close to the end if I see what's happening. So what I'm going to do is move these over so I have enough room. And then I'm going to factor out a 2. So I have 2 times 1 plus sine x over cosine x times 1 plus sine x. 1 plus sine x's are going to cancel. So I end up with 2 over cosine x, and that equals 2 secant x, and I'm done. So that one was a little bit more involved. I had to do a little bit more there. I had to recognize that cosine squared plus sine squared is 1, and they weren't right next to each other. And then I had to factor out a 2 and cancel some things off. Okay, final problem. Going to work with the left-hand side. When we're working with the left-hand side here, I'm going to do the last thing that we haven't talked about from those bullet points up top, and I'm going to multiply by the conjugate. So remember, just way back when, if I had 3 plus 2i, the conjugate was 3 minus 2i. And we did that with radicals, and we did it with i's and stuff. Well, we can do it in these problems too. So I'm going to work with the left-hand side. I'm going to multiply the top and bottom by the conjugate of the denominator. And the reason why I want to do that, well, now the numerator ends up being cosine x times 1 plus sine x. The denominator now is 1 minus sine squared x. So notice that the conjugate, when I distribute, when I end up distributing with the conjugate, it gets rid of all the middle terms, just like it always did in previous units when we were multiplying by the conjugate. So this is a major thing that we're going to want to use in some trig identities to help us out. 1 minus sine squared, we've done this many times now. We hopefully know that that's cosine squared. And now one of the cosines cancels out, so I have 1 plus sine x divided by cosine x. And then I end up with secant plus tangent. Well, if I have the denominator is one term, I can rewrite this as 1 over cosine plus sine over cosine. And that ends up equaling secant plus tangent. And that is exactly the right side.